The same LED code, but in different way we are going to see. Actually, it is kind of device driver level development. So before that, what we see is that we are directly using the gpio.h file. So we are directly calling the function, and inside function, gpio set, gpio pin mode change kind of thing. So we are automatically we are calling that function. We are setting that using the macros. But when it comes to the real-time project, so if we use this function, so it will consume a lot of memory space. So for that, we have to develop our own memory mapping and direct register access to reduce the memory. So that is called device driver development. So when it comes to the ESP32 boards, we can directly use the register map. So if you want to add another sensor or peripheral, so while connecting do this normal communication, so that time also you can use the direct register mapping and you can directly access the registers. So this is the basic setup. So first we are going to see the basic program for that. As usual, we have written the normal std IO, and we have written task and free autos, the basic task which is used inside the program. Then we are using the macro, register macro, as you can see, GPO out W1 TS register. So this register is uh, it is in the hex value. So this is the register value. So where you can see that register means you can go to the data sheet. So this is the ESP32 technical reference manual. So inside that register summary it will be there. So as you can see, this is the GPO out W1 TS register. So what is the description means? This is the GPO 031 output register. So this is for set. So last yes means this is for set. And another one is that same GPO out W1 TC. It is for clear. So this is the address of that specific register. So this is both right, and WO means it's only write only. R and W means read and write. So this is the definition. So in this register you can only write. So that first register W1 TS means it is for set register, and this is for clear register. So this is where you can see the different registers. So what these things are doing. So whether it is readable or writable, so that you can see. So yeah, we are going to our code. We have a two register, one for setting that LED pin, actually second pin, and this is for the uh, clearing that pin. Then we are doing the enable register. So we have to, as you can see, you can go and check that in datasheet. So this is that the GPU enable bit is a bit in either. So this is to set the GPU 31. So if you set, then it is it a input or output, so that you have to mention. So in the register only holding that, whether is it a input or output kind of thing. Then this is a uh, GPU out register. So that we can go and check what is that register. So this is for the output register. So this register will give us the specific that GPU 31 pin status, whether it is on or off kind of things it will give. It is read and writeable. So you can go to that. So this is the register map, how that will give. So you can see. Yeah. So this is kind of it will give whether if that GPA is high, it will give us a 1. If it is a 0, if it is off, then it will give us a 0. So it is kind of status of that specific register, specific pin. So these are the four setting. This is for setting, and this is for clearing, and this is for enabling that pin. This is for getting the status of the pin. Then we declare one GPU pin as a 2. Then we have declared one void delay millisecond. So this is ms, how much millisecond it has to wait, and it is a ported period ms. So you can go to that. So this is kind of delay. So it's kind of trigger timeout. So it will give some internal clock frequency. According to that, it will give the delay. So this is the calculation for the giving the delay. So we are giving in the delay function, we return some, we can directly use that, but yeah, we are creating some function. Rather than calling this vtask delay directly, we can use this function. Then we have one print register in binary. So we have to print every register in the binary format. So that's what we are writing that. So we will see what is volatile and what is unsigned thing. And yeah, then we came to app mine. So what now we are going to do is that we are so we need to print these things. So what we are going to do is that here we already declared that as a register. Then we are casting that register into volatile unsigned integer. So volatile unsigned integer means, so what is volatile means is that, so when it comes to embedded system, we can declare two type identifiers. One is constant and another one is volatile. So constant means it will be non-changeable. So the constant variable, like if you declare the constant variable pi as 3.4, so it is a constant value. So you don't need to change it. So it will thoroughly the same value in the full program run. And volatile in other case. So some of the functions, like in this case, so this register will be written by the hardware or read by the hardware. It will not be programmatically changeable. So this variable, especially the GPU register and enable GPU register, so these are the hardware dependent variables. So which the even we can manipulate through the program, but the value changes in the register only done by the hardware, not by the code. We can manipulate it, but we don't know whether it is changed or not. So only the hardware can handle this register and value changes. So in that kind of conditions, we have to declare that variable as a volatile. Why we have to declare that as a volatile means, while the after you write the code, if you build that, so the compiler tries to optimize all the lines in the code. So it will separate the every variable to the separate memory section. So when it comes to that register kind of variable, so it is dependent on the hardware variables. If compiler mistakenly optimize that register into any other mapping kind of things, then when that register try to access it, it can't access it, because the code doesn't change that specific this specific variable, only hardware changing it. So if mistakenly if the compiler optimize it, hardware can't change it, or you can't read that register, or you can't write the register properly. That's why we have to tell the compiler that this is a hardware dependent variable, so don't optimize it. So in that case, we need to use the volatile. Then again we are doing the volatile and GPU out W1TS, like we have to print that register. That's why we are doing it. Likewise, yeah, what we are doing is that this is the normal register. Then we are doing the casting. Casting means it is a defined register map. We have to change the uh, uh, data type of that register map. So now we are doing the casting. We are converting that this register type into volatile unsigned integer type. Then we are storing that into unsigned integer pointer GPU pin. So why we are using the pointer means, yeah, address. So we need a pointer to do that. Then yeah, likewise we are doing that for everything. Then what we are doing is that we are enabling that register. If you enable that register only, you can access that GPU, because only we can read and write it. So what we are doing is that same as that time we have seen the bit, right? Bitwise setting clear and toggle. So what we are doing is that we are uh, toggling, we are setting that specific register into one. So we set that GPU open means, so likewise if the register have a 0000, then we are doing the left shift of 2, 1 into 2. So we have to toggle that to 2 because GPU open is 2. Then it will change this bit to 1. So that's what we are doing. So if we set that specific pin to 1, then register the specific pin will be changed into 1. It means that it is set, that GPIO specific pin is now enabled. Then we are printing the basic first registers, like it will store what are the values inside that binary registers. Then it will print. Then what we are doing is that we are trying to blink the LED, same as we have opened the while. Same as here, what we are doing is that we are registering. Here we are enabling it, right? So same as we are enabling this register. Whenever we are going to use that specific register, we have to cast it using the pointer. Then only we can access that pointer, which means access that address, to change the set and clear bit. So here what we are doing is that same as we are setting that W1TS set register to 1, same as here. Same whatever we are doing here is we are doing that thing, same thing here. Then yeah, this register set at, which means that the LED became on. LED, that specific GPU became on. Then again we are printing it. Then we are giving some delay. Then again what we are doing is that we are clearing the bit. So if we set the W1TS, which means set register to 1, then the LED will on. If we set the clear register to 1, the LED will off. So every time we are printing the register. Okay, so now we are building that project. So this is the program, so we are building it. So once we get the output, we can see that output clearly, and the program also we can easily understand. So now the build is completed. Now we are passing the device. What? So the flash also completed. Then we are going to the serial monitor. So as you can see, we are printing the registers value. First printf. So this is here what we are printing. So as you can see, we are printing everything, like what is that W1TS register, so W1TC register. So these are the register values, and the enable register first is set to 1, as you can see. So what we are doing is that we already set that enable register, and yeah, here you can see the second 0 1 2, because we are doing the left shift, so it will start from the least significant bit. And yeah, so the one that 0 1 2 pin will become 1, so that specific 30 first GPU pin is enabled. Then we are printing the actual register value of that specific pin. So as you can see, everything became 0 because that LED pin is now 0. Then we are switching on the LED here. Here we switch on the LED. So here also you can see we are setting the register, but you can't see the register value as one because it is a register. So the hardware only doing the changes. So you can't see the register bit changes because we are setting that register to 1. It will not affect the register mapping. So we said that, but when you see the specific output of that pin, so it will become 1. So when we switch off that, so this is the LED off stated. When you specifically check that, after you clear that bit, you can see that again the bit became, all bit became 0. So this is how you can directly access the register and switch off or set or clear bit or switch on the GPIO, like highing that GPIO or lowering that GPIO. That how you can do. So this is the basic, same as what we previously see, that same thing will happen, like LED will blink. But now we are directly accessing the register. So this code will help us to understand how we can directly access the register using the data sheet of the specific microcontroller. So when it comes to the sensor, they also have a data sheet. They also have a specific register. So if you want to access the sensor or peripheral, so that specific register you have to do, and you have to, in that case you have to write and read that specific register. So that time it may change. So this is a basic level of understanding the device driver and how to write the GPIO.